All right, let's do page 3. Number 16, we have 3p1. You could just plug that into your calculators using that math button if you have a graphing calculator, or if you have any other kind of calculator that has that button. Otherwise, 3p1 means 3 factorial over 3 minus 1 factorial. So 3 factorial over 2 factorial. Again, you could get out your calculator and use your factorial button, but 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. Those cancel, leaving 3. So 16 is C. Same method for 17, just bigger numbers. So 14p7 means 14 factorial over 14 minus 7 factorial. So that's 14 times 13, 12, 11, 10, 9, 8. And then I'm going to stop here at 7 factorial because 14 minus 7 here is 7 factorial. And I can get those two to cancel. So in my calculator, I'm just going to put 14 times 13 times 12 times 11 times 10 times 9 times 8. Again, you could plug this in as this, but I like to do the canceling. So that works out to 17,297,280. Number 18. Suppose a word is any string of letters. How many 3-letter words can you make from the letters Regina if you don't repeat? And so the thing about Regina is it doesn't have any repeaters. So that's going to be 6p3. You have 6 letters, pick 3. So that's going to be 6 factorial over 6 minus 3 factorial, which is 6 factorial over 3 factorial. 6 times 5 times 4 times 3 factorial over 3 factorial. Leaves me 6 times 5 times 4. 6 times 5 is 30 times 4 is 120. Number 19, just a tiny bit different. It says, suppose a word is any string of letters. How many 2-letter words could you make from the letters Lethbridge if you don't want to repeat any letters? So the thing about Lethbridge is it has 2 E's. So if you don't want to repeat any of the letters, you can't choose anything that has EE. So just eliminate it, and instead of having 10 to pick out of, just call it 9. So this one's just 9p2. So 9 factorial, I start to cheat after a while. I know it's going to be 9 minus 2 is 7 factorial. This is 9 times 8 times 7 factorial over 7 factorial. So there's your 72. 20, just cut it out. I'm not going to ask you 20. 21, we get to use our algebra. So we have n minus 2 p2 equals 30. So it looks kind of complicated, but what we have to do is write this in its expanded form. So remember that if it's this p2, it is n minus 2 factorial over n minus 2 minus 2 factorial. So the bottom is always, let's get out a highlighter, this minus this. So that's how come I have n minus 2 minus 2. That equals 30. So I'll have n minus 2 factorial over n minus 4. Factorial makes 30. I'm going to expand the top so that I can cancel because I have to get lower. So I have n minus 2, n minus 3, n minus 4 factorial. Remember, factorial, I'm getting one less every time, over n minus 4 factorial equals 30. I'm not even going to do this question, so I'm going to keep going and use this space. Cancels, leaving n minus 2, n minus 3 equals 30. I'm going to FOIL, so I'm going to get n squared minus 5n plus 6 makes 30. I'm going to subtract 30 from both sides. N squared minus 5n minus 24 equals 0. Now I'm going to factor two things that multiply to negative 24 and add to 5. So to multiply to 24, I'm going to use 8 and 3. The 8 needs to be negative, the 3 has to be positive, so therefore n is either 8 or negative 3. If I plug, remember this was my question over here, if I plug 8 in, I'm fine. 8 minus 2 is 6, 8 minus 4 is 4, I'm still above 0, but plugging in negative 3, I'd have negative 3 minus 2 is negative 5. That's not going to work. So my solution is D. Okay, 23. How many ways can 8 friends stand in a row for a photograph of Molly, Krista, and Simone always stand together? Doesn't that always happen? Don't they always stand together? So anyway, if I make 8 spots for them, 4, 5, 6, 7, 8, I'm always going to have Molly, Krista, and Simone standing together. So that's kind of like a group. So you got to think of this as a group, and then think of the other one as a group as well. So I've got really 2 groups. So I'm going to look at what this group can be. So out of 3, pick 3. And then this one's got, the second one has 6. So out of 6, put them anywhere. So 3, pick 3 is 6. 6p6 is 720. So when I multiply those together, I get 4320. Number 24 is just straight math work. I don't like punching them into my calculator. I like to I like to expand and cancel all I can. So I have 9 times 8 times 7 times 6, 5, 4, 3, 2. I never put the 1 because anything times 1 doesn't change. 3 factorials are 3 times 2 times 1, which are all 6s. So 6, 6, and 6. So we can start with, this can get rid of that. 3 times 2 is 6. That can get rid of that. And then I can think, well, 6 has a 3 in it. So if I cancel a 3 out of it, I'm left with a 2. If I cancel a 3 out of that, I'm left with a 3. And then this 2 can cancel that. So my answer is 3 times 8 times 7 times 5 times 2, which gives me 1680. And the last one on this page, let's get out of red. Same thing. So right here, I know this part. I know there's lots of canceling. So I'm going to go 12 times 11 times 10 times 9 factorial. I'm going to stop there. I'm not going to write everything out because I have a 9 factorial on the bottom. That gets rid of that. 2 factorial is 2. Oops, sorry about that. 2 factorial is just 2. So if I cancel that and be left with a 6. 6 times 11 times 10. 660. Almost done. Keep going.